So in this lecture we will be going over first order ODEs. Our first example is the following right here. Y prime is equal to y times cosine of x, with the initial condition that y of 0 needs to be 1. So the first thing, if you see something like this where you just have the y on the right hand side, you can divide it to get it on the other side with no other variables. My approach would be that you rewrite this y prime as dy over dx, and this is equal to y times cosine of x. Now we want to multiply by dx, so we have the dx on this side, and we want to divide by y, so we have it on this side. Let's do this. So we have dy over y is equal to cosine of x dx. Now we have separated our variables. There's just a y on this side, we have just x on this side, so we will just integrate it to get rid of the dy and the dx. So we will just take the integral of dy over y is equal to the integral of cosine of x dx, and this is the ln of y is equal to sine x plus c. Note that on the left hand side right here we don't need the plus c integration constant, because we can just put this integrating constant from the left hand side and from the right integral together, so it's just one constant. Now to get rid of the ln we just e everything, so we have that y is equal to e sine x plus c. Note that this right here is the same as e sine x times e to the c. E to the c is just another constant. So we have a, so we just rewrite this as a. So we have a e to the sine x. Let's write it down here. We have our y of x is equal to a e sine of x. And now we can just plug in our initial condition. We have y of 0 is equal to 2, and this needs to be equal to a e sine of 0. Note that sine of 0 is 0 e, so e to the e0 is 1. So we just have that a is equal to 2. So our function y of x is equal to 2e sine of x. Yes. And that's our final solution. Now let's jump to the second example. This is the second example right here. We have y prime plus y is equal to e to the x with the initial condition that y of 0 is equal to 1. So here we will solve it with integration factors. So note that we can just rewrite this whole expression as y prime plus p of x y is equal to q of x. What we did is we just said that e to the power of x is equal to q of x, and right here in this expression we just add a p of x. We just multiplied with this. So we have basically substituted p of x is equal to 1 and q of x is equal to e to the x, because note that if px is 1 and we multiplied right here, it just stays 0, and q of x is equal to e to the x, so it's the same expression. We didn't manipulate it in any illegal way. So now what we do is we just call function mu of x, and this is equal to the integrating factor. That's the whole trick in solving this ODE. We just say it's e to the integral of px dx. That's just the general approach to solve this problem. And this is just the same as e to the x, because p of x is 1. If we integrate it, we are just left with e to the x. Now what we want to do is multiply our whole equation with this integrating factor. If we multiply everything, we have, note that we have the function right here, and we want to multiply everything, so we get e to the x y prime plus y e to the x is equal to d dx e to the x y, which is equal to e to x. Note that right here in this expression right here, we can just pull out the e to the x, and if you look at this right here and with the rules to differentiate our functions, we get that those are the same functions. If we just plug everything in, we have that e to the x y is equal to 1/2 e to x plus c. Now we can just solve everything for y. So we have y is equal to 1/2 e to the x plus c e to the minus x. Note that if we get our e to the x to this part right here, we have e to the 2x divided by e to the x, which is just e to the x. So this is our function itself. We now want to determine our coefficients. We have y of 0 is equal to 1. If we plug everything in, we have e to the 0. So note that e to the 0 is just 1. So we get that we have 1/2 plus c, because this right here is 1. So the entire expression is 1/2. This right here is 1. So we have c divided by 1, which is just c. So we want that 1 is equal to 1/2 plus c. This implies that c is equal to 1/2. So we can just plug everything in, and we get 1/2 e to the x plus 1/2 e to the minus x. And that's our final solution. Now let's get to the third example. The third example is a bit different because we don't just want to find our function itself, but we want to find y of pi. So we want to plug in pi into our final function and see what we get. Why don't you try to solve this problem by yourself? By now you should be able to solve this ODE by yourself. If you need a tip on how to solve it, note that y prime is equal to sine x multiplied by minus y plus 1. Now try to solve it, pause this video, and when you solved it, let's go back to the video and check if you did it right. So what do? We divide everything on this side to the other side, and rewrite our y prime as dy dx. So let's just do it. We have 1 divided by y minus 1 dy over dx is equal to minus sine of x. Note that right here at the top I just pulled out the minus 1, so we have minus sine, and this right here is a y minus 1, so we have the following expression right here. It's up to you how you want to solve it, but I just prefer this way. So now we have our y's on this side and our x on the other side, so we just multiply by dx, so we just can integrate both sides. So we have 1 divided by y minus 1 dy is equal to minus sine of x dx. Now we can integrate both sides, so we have the integral of 1 divided by y minus 1 dy is equal to minus sine. I forgot the integral sign. It's the same as the integral of minus sine of x dx. If we solve these integrals, we get that we have the ln of y minus 1 is equal to the cosine of x plus c. We can just e everything out like we did in the first example, so we got that y minus 1 is equal to e to the cosine of x plus c. Note that we can rewrite this plus c stuff again as a e cosine of x, because this plus c is the same as if we multiplied e to the power of cosine x times e to the power of c, which is just a constant by itself. So this implies that our y of x is equal to 1 plus a e to the cosine of x. Note that this plus 1 comes from here. We just added plus 1 on both sides, so we just have our y on one hand of the equation and the x and everything else on the other side. So now that we separated our y from our equation, we can solve for the condition itself. We have the condition that y of 0 is equal to 0, which should be equal to 1 plus a e to the cosine of 0. And if we solve everything, the cosine of 0 is 1. So we have 0 is equal to 1 plus a e to the 1, which is just the same as if we have minus 1 over e. Note that if we have 1 divided by e negative, we have that right here. We would just have minus 1 and 1 minus 1 is 0. So this implies that y of x is equal to 1 minus e to the cosine of x minus 1. Why do we have this minus 1? Because e to the right here we calculated that it's minus 1 over e. So cosine of x divided by e and everything minus is just the same as minus e cosine of x times e to the minus 1, which is the same as minus e cosine of x minus 1. If you don't know what I did right here, you should probably go over your power rules again, and once you get them, this should be pretty easy stuff. So our final solution can now be calculated. Y of pi is equal to 1 minus e to the cosine of pi minus 1 is equal to cosine of pi is minus 1. So we have minus 1, which is minus 2. So we have 1 minus e to the power of minus 2. And that's our final solution. That's it for today's video. I hope you enjoyed it. Please don't forget to like and subscribe. And until next time, happy learning.